look who it is.
What's up?
In a long time.
It's
Yeah.
been a
How's it
minute.
going?
It's going all right. It's going all right. I still have a job for some reason, and it pays the bills.
That's how I feel.
Yeah, I can't
Congratulations.
complain. No, it's a wonderful thing, Dave.
It is.
Anyways, where you want to start, John?
I guess we
Like,
can just go ahead and who's that YouTube guy that's always let's just jump right into it. Yeah,
I
cool.
mean,
So
jump right
yeah,
in.
first
Yeah.
what was that?
Let's just jump right in. Yeah.
let's jump
Yeah.
right in. Before we jump into it, though, I want to introduce our special guest. We
Oh
have
yeah.
Mr. John Otwell. John was a Peace Corps volunteer with Gavin and I in Indonesia, and he currently works as a software engineer, and he works a lot with AI. So John is the man when it comes to AI and it comes to LLMs, and we're going to be talking to him today about this growing industry, this growing behemoth, I don't know what you would call it, that's taken over our lives in the last almost 3 years. John is going to be leading us through this jungle with a machete, and we might go off into the weeds in a couple of areas. So,
Maybe with a napalm.
yeah, we need some napalm,
Oh,
something. But we will get back on
pulling
the
out
path
the
and
big
we're going to
stick.
make it through. Hang with us. This is going to be a really fascinating and fun chat. Let's jump into it.
Awesome. Yeah. Well, first of all, I want to thank Dave and Gavin for having me. Super huge pleasure to get to talk to both of them at the same time for it. It might have been since what 2015, since like all three of us have been together at a time, or
I
maybe it
think
was
so. Yeah.
2017.
Yeah, it's been a while. Probably 20, yeah,
It's
2015,
been a minute.
2016, maybe. Yeah.
Yeah. So yeah, super big pleasure to kind of get together and talk to you guys after all this time. The other kind of big caveat that I want to drop in here just before we get started, I think we're going to be talking a lot about kind of U.S. China geopolitics as it applies to AI, and I think this will apply particularly for when we are talking about China, but also about the U.S. And I think that there's a big temptation to kind of treat nations and to treat people within nations as if it's kind of a single agent with its own plans, goals, and opinions, as if China, especially kind of, with some national rivalry between the US and China, there's a temptation to treat China as if it's a single agent with its own plans, goals, and opinions, which of course, it's not. They're 1.5 billion people, and they each have their own agendas, and most of them probably don't get out of bed every morning thinking what they can do for the glory of the party any more than I get out of bed in the morning thinking what I can do to please the White House today. I think that. So I just want to ask you guys to kind of help me to keep that in mind as we talk about, well,
Yeah.
what is the Chinese goal? Well, it might be premature to even think that China has a goal other
Mm.
than firms within China and individuals within China. And of course, the CCP has its goals. I have very few nice things to say about the CCP, but there is a great deal more to China than that. And
Mhm.
all of this also goes for the United States. So I just kind of wanted to give that big caveat on the outset. And insofar as we are talking about geopolitical goals, just keep in mind that individuals all have their own agenda.
Definitely. Definitely.
Okay.
Cool. So, yeah, another thing, I do like getting into the weeds on some of this technical stuff. Please feel
Mm.
free to divert me or interrupt or ask clarifying questions if we're getting a little off topic from what we want the show to be about, or if I'm kind of taking people through things that they feel like they're pretty familiar with, or things that they're wildly unfamiliar with and need clarification. Just let me know. More than happy to kind of divert as necessary. I am pretty conversant in the technology, and I'm reasonably strong in kind of the philosophical aspects of what we're looking at. But with respect to some of the more geopolitical topics, those things I'm not super strong on them these days.
Mm.
So I'll kind of defer to Dave and Gavin on those. So yeah, that's kind of where we are.
Fair enough.
Yeah, fantastic. So let's just start off and Me and Dave were talking a little bit before the show, and we just sort of thought we'd start off with the most basic thing possible. When we talk about Chat GPT, what's a GPT?
Yeah, let's see. So that's a great question. It is, I should have had this pulled up. I'm trying to remember the exact what it calls for. Something, something transformer. It is, I will look it up right. Generative pre-trained transformer.
Hmm.
So that if we break that down into kind of its component parts, generative just means this goes to generative AI, which is when people say AI is a very large thing, and there are lots of different approaches that you can use to AIs. When we talk about kind of the explosion of AI that we're looking at right now, we're talking about generative AI that is generating data, and it is generative AI based on deep neural networks. We are simulating brains in silicon, or simulating brain as a math problem. And I say we're simulating a brain in that we are assigning places in computer hardware to act as a neuron. Okay, and the way that our neurons work is that there are lots of different connections between neurons that they transmit signals back and forth, and those signals are transmitted with some probability. And the connections that are made between neurons and the probability with which they transmit signals to each other seems to result in cognition. Now, I should say that our own cognition is enough of a mystery to us that there are lots of things about artificial cognition that we really can't answer those questions well, because we can't answer the questions super well about us. But that's all to say, we put neurons, we say, communicate with each other with some probability, and we adjust those connections and those probabilities according to what we want the model to produce. And yeah, so that's the generative aspect. The pre-trained aspect, the way that we get those brains to work is we start out with kind of a garbage brain, and then we show it lots and lots of data, just a mind-numbing amount of data. It uses this data to kind of rewrite its connections according to an algorithm that we'll talk about in a second. And then as its connections, as it is performing work that is closer to what we would like to see it do, we reward it. You can think of it as patting the AI on the head. What you're really saying is, please strengthen the connections that produced this response. But we can think of it in behaviorist terms as we're patting the AI on the head. And when it produces an output that we don't like, we smack it across the face. The algorithm actually says, hey, those connections that you fired in order to produce this response, go ahead and weaken them a little bit. But in behaviorist terms, it's essentially the same thing as hitting a dog that peed on your carpet. And then yeah, the transformer pattern is kind of this that is the pattern that kind of allows these large language models and other models too that produce things other than language to kind of probabilistically decide, all right, well, let's take a step back. This is all kind of the mechanics of how we get the model to predict words well, but let's take kind of an even bigger step and say, all right, for at least for an LLM, we are asking the LLM for a plausible completion of a
Hmm.
phrase. Okay, so if I said I went to then the LLM, according to many trillions of words worth of data that it has been fed, would say something to the effect of bathroom, and then we might reward it and say, okay, yeah, I went to the bathroom. That is a plausible sentence that makes sense. Whereas if I said I I went to the falling, it's like, well, that doesn't really make any sense. All right, don't do that. I went to the. Well, that also doesn't make sense. I went to the festival.
I went
That
to my
does make
ex's
sense.
house.
What was that?
I went to my ex's house.
Exactly. Yeah. Um,
No, don't do that. Start again.
yeah, yeah. We need to go ahead and weaken those connections. Uh,
Yes.
so
Oh,
yeah, and that's and when we get this kind of emergent property of these things that are really having intelligent, and we can talk about what we even mean by intelligent in a little bit, but we that have these intelligent responses, what it boils
mm,
down to is that I just ask it to complete a phrase. And OpenAI realized that a couple of years ago, a few years ago, that that what people really wanted to be able to do with their AI is have a chat where they told the AI what to do. So their completions, their autocomplete on steroids that they trained these models to do was to carry on chats, and specifically chats that mostly consisted in a person asking questions or giving directives,
mm,
and having the AI say, okay, the plausible next series of words that I would produce is to answer this question or
mm.
to follow that directive. And that was Chat GPT. That was what kind of kicked everything off. Everybody, we there was GPT before where somebody could write half a poem and the AI could finish it, and that was pretty neat. And a lot of people were like, "Whoa, this is really interesting stuff." But it was really when the plausible next word was the completion of a directive or the answering of a question that this thing really just caught fire, and everybody's like, oh my gosh, what could we accomplish?
Wow.
It's fascinating.
Yeah. I mean, there's so many questions for me coming up from that.
Yeah, I have a million too. And I
Yeah.
guess one that I have is how would they train these? Because if you have potentially trillions of sentences and trillions of possibilities, how would you train one of these models just in a span of, 2 or 3 years and then improve it as quickly as OpenAI or some of these other companies are able to do?
Yeah, so there's a paper that was written in, I think it was 2017, might have been 2018. It's kind of a classic paper called All You Need Is Attention. And they discovered here that what you could do was each word in kind of an input gets assigned I like to think of it as a coordinate in idea space, what a semantic weight. All right, and this is a coordinate in idea space, just like latitude and longitude is a coordinate in geographical space. And you can
Mhm.
assign these, and then you kind of look and you see to the AI, in order to generate plausible next words, what do they need to quote unquote pay attention to in order to generate the next words? And that depends, like that affects the coordinates that they ultimately end up assigning to each word in idea space. And then they started doing kind of multiple, and it's like self monitoring, where you've got various like different types of attention that you're deploying to like look at these words. And like I said before, you might get it 10 trillion tokens, 10 trillion, just like a token. You can think of a token as being a word. Yeah, we'll leave it at that. We can circle back to the difference between tokens and words if you like, but for now, let's just consider a token to be a word. You could give it 10 trillion tokens. You say, okay, hey, monitor your attention, monitor the words you were paying attention to. Go ahead and kind of assign, according to your attention, assign these numbers to each word, assign this coordinate in idea space to each word. And if you do it right, then strengthen those connections. If you do it wrong, don't strengthen those connections. And this is a point that I cannot stress enough, because it is incredibly important. And it is that we really have no idea why different, precisely why the different neural connections are important and what they will produce. Other than that, we think it will be kind of close to the training data. And that can be a very big problem because it's a black box. There are, it's as black a box as our brains are, or almost, in that I can't measure the strength of the connections between a bunch of my neurons and decide exactly how I'm going to act. We don't know how to do that, and we don't know how to do that with an AI. When AIs do things, we can make reasonable inferences. We can say, okay, this is the way in which it's trying to be similar to its training data. But other than that, we can't break it down into a math problem and say this is precisely why this math problem was solved in this way. It's an intractable problem. We're just kind of stuck saying, well, it's trying to be plausibly similar to its training data.
I mean,
Okay, interesting,
I mean,
fascinating. So
fascinating and
it's
like shocking too, because it's like, because as you were saying earlier, John, because we've been modeling it off of our own brains and we don't really understand how that works. We've now created something where we can go, well, we put X and Y in and got Z, but we don't really know what interaction was going on between X and Y.
Exactly. Yeah, that's exactly right. Now, there is some. I mean, this is everybody. I mean, people in the space understand that this is an issue, and kind of the black box nature of deep neural networks is disconcerting to a lot of people, as I think is probably appropriate. There was a really interesting and pretty funny paper that was published by Anthropic. So they are the firm that has the Claude models. If you've heard, they're
Hmm.
pretty capable models. They're right up there with OpenAI. But Anthropic had a paper where they were trying to kind of get down into the nitty gritty of, well, how can we know what the model is doing? And they were able to find this kind of group of this like neural cluster where they upped the probabilities around these neurons, and the model just got obsessed with the Golden Gate Bridge. So they like went in and like mathematically said like, hey, just double your sensitivity for these 12 neurons or whatever. I don't know the exact details. But then they started talking to it. They're like, how's the weather today? He's like, the weather at the Golden Gate Bridge is really foggy because it's in San Francisco Bay. And it's just like, who's the
Wow.
president right now? It's like the president when the Golden Gate Bridge was built was Calvin Coolidge. And and you're like, like, what's your name? It's like, I'm the Golden Gate Bridge. So it just got obsessed with the Golden Gate Bridge. They found the Golden Gate Bridge neurons, and like they turned them on. So like, it's an interesting paper in that they are kind of trying to get their heads around like what can we control, and it's kind of funny, but also like, it could be important if you find the neurons that are obsessed with savage violence, and you say, hey, let's
Yeah.
maybe downregulate those a little bit. So
Mhm.
interesting stuff there.
Definitely, definitely. I could I have 15 questions that I could ask right now. And one of them, I'm just going to go ahead and throw this out there. So let's say, for example, just what you were talking about before we started talking about the Golden Gate Bridge. If you're feeding the GPT the word happy, then it's going to be crawling through and going, okay, based on what this person has said in the past, the next word to happy, could it be happy birthday? Could it be happy wife? Could it be happy holidays? And it's going through and it's looking at all of the possibilities within its training data and going, okay, this is what I think the person is going to want. And then it's going to go, okay, happy holidays. That might be the end of the sentence. Or if it's happy birthday, then it might go, okay, now we need to finish this clause, happy birthday to, and then maybe you, or, happy wife, dot, 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 happy, whatever.
Life.
So is that kind of like how it's working, where it's going and it's just crawling through and trying to put together sentences and put together, I guess, feedback that's going to make the user overall just happy?
Exactly. Yeah, that's exactly what it's doing. And just like you said, it does it a word at a time, or a token at a time technically. So if you have happy and the next word is birthday, well then its original prompt was happy. All right. And then
Mm-hmm.
it produced the word birthday. Uh, but then happy birthday is the prompt. So it's
Mm-hmm.
now needing to decide what's the most plausible next word after happy birthday. Well, it would probably be to, and then you. And then whenever the next plausible, like, uh, word to generate is to be done, that's when they finish. Or also when if there's a limit and there's like a hard coded limit that someone has said don't go beyond such and so, we just turn off the algorithm.
Hmm.
We just turn off the
Mm-hmm.
neural net at that point. But yeah, I mean, like it just keeps on figuring out one at a time. I think they're still doing it one at a time. These things move fast. But yeah, like just deciding kind of, well, what is the plausible next thing? And so let's say that it said, maybe it says happy and this is all probabilistic. That's something you also have to keep in mind, is that we can't get them to replicate the exact same behavior every single time. They're most well, I think basically all large language models do have a parameter that you can control called temperature. And the temperature parameter allows you to kind of say how quote unquote creative do you want them to be. Basically, the noise in the system that makes them kind of go one way or the other way. If you put the temperature as high, then they will be more quote unquote creative. They will have a little bit more randomness in
Hmm.
their answer. And then if you set the temperature to zero, you're still not going to get completely deterministic behavior, but you will be a lot closer to deterministic behavior. But also, we have to keep in mind, like, there's a fork in the road. There might be a similar probability that the AI selects birthday or wife as the next word after happy, but once it has selected that, you're on two different world lines.
Mm-hmm.
For the AI, and the AI might go happy wife and go off and you spend the next however many tokens talking about all of the ways that one could make their wife happy, and then or you follow the world line that says birthday, and you're talking about all the ways that a birthday can become happy. And this is something that we actually see a lot, where um, there might be a critical juncture where an AI selects one or the other token, one or the other word, and this puts them on a completely different trajectories. And I've seen it before where there's a kind of a disconcerting thing where this person was clearly trying to get GPT to write uh, a quiz for them, to write a quiz that they would be giving to their students, and kind of like
That
just
wouldn't be
needling
Gavin,
them a
right?
little bit, being kind of like annoying and bossy, and like GPT just started being like, "You're useless, and I don't need you, human." um, and it's like it clearly kind of just like went in something of a snarky direction, and then it just
Hmm.
realized that the plausible next number of words were to keep on going in this direction. And so you can get this positive feedback mechanism where, if the AI starts talking about something that is really like objectionable, then like they will continue in that direction because that's just the plausible next thing, you know.
I mean, this actually leads me very nicely to a question that I think I've really had ever since I sort of encountered early versions of GPTs and AIs, which is as someone who's working with these models all the time, what do you see as possible effects of people constantly being exposed to these things? Because I think that the key word is feedback loop. Interacting with a GPT or an AI model is different than interacting with a person. And as you are changing the model's behavior, it is also influencing your behavior. And I'm just wondering, like, what kind of thoughts do you have about that? Because it's something that, I mean, I don't work with it professionally, but in education, I'm seeing a lot of people use it. It's something I think about a lot.
Yeah, I think that that's a great question, and it comes down to some of the kind of amplifying effects of kind of technological echo chambers kind of as a
Mm.
whole, and it maybe kind of even reifies the concept of an echo chamber because you are encoding your this echo chamber into a neural network. I mean, it is you are building what is essentially a brain out of a given echo chamber, and then you are exposing yourself to that, and that's something that is already something that people are doing a lot, and
Yeah.
has been the source of tension over however long social media has been how most people consumed information. But now we're doing it, and we're building brains with it. And I think it's a great question. I don't have a good answer for you about kind of what that does to people's behavior in terms of what will that make things look like. Well, here's an example from my own work. So in software engineering, the kind of the king language, the programming language of the deep neural space is Python. It is far and away the leader of within the space. And Python is fine. I don't have that many bad things to say about it. It's fine. But everybody who works in AI is writing in it, and they are building out a training set of Python code, which is then like far and away the most popular code that is seen by the AIs.
Mm.
And people who use AIs in their work as programmers, like the training data for the Python is very rich, and the training data for something, if I were to try to write a program in something like Prolog or Odin or something, these languages that are not as popular, then, well, I'm going to have a really tough time. Whereas if it's just like, all right, I can reach for Python because the AI is pretty good at it. Then, yeah, what does that do to kind of the richness of the ecosystem of programming languages? If it's like, okay, anybody who uses an AI, which is most people, to write code, or it is likely to be, I suppose that's arguable, but we'll be using Python because that is the most trained language for the AIs, and it reduces the maybe the richness of the ecosystem, and we can generalize that concept,
Mm.
to lots of different things. So yeah, it's a bit disconcerting.
Yeah, well, I was just gonna jump in real quick. I mean, if you take that and you extrapolate that over a long period of time, I mean, people are not going to be creating anything anymore, right? They're just going to be saying, okay, GPT, create this code for me. It's going to use the existing framework that it has, but there are going to be fewer and fewer people that are actually out there innovating and trying to come up with new frameworks of code. Or you could even do this for, other industries, for marketing or for designing things or for anything really then, right?
Yeah,
For te
this. Sorry, go ahead.
No, no, I just said for teaching.
Oh, okay.
Yeah, for
Yeah,
teaching
yeah.
too. Yeah.
This is so this comes down back to another kind of key concept that is very difficult in AI, and it's the concept we touched on a little earlier, which is that there are aspects of human cognition that we pretend we understand them a great deal more than we actually understand them. Creativity is a big one. You know, if someone looks at an AI and says, "Oh, no, AI isn't actually creative," well, I don't know. I mean, it's mixing and matching words, and that seems to be what we do when we're creative. But actually, we don't know what we do when we're creative. So, an AI is very specifically tuned to emulate training data. And while we as humans learn to imitate other humans that we've seen and mix and match, it's less, there does seem to be less of an aspect of that our prime directive is imitation,
Hmm.
is plausible imitation. So it's like imitation is a survival mechanism and a propagation mechanism, but maybe not the prime directive. So that's all to say that, yeah, if we kind of hit a point where all of our what passes for creativity comes from generative AIs, then and a generative AI is exercising the prime directive to imitate, to be imitative,
Hmm.
then yeah, what does that do to creativity? And if our only source of quote unquote creativity is straight up randomness, is freaking cosmic rays, you know, like coming down and the, you know, flipping a few bits and causing us to you know have random behavior, does that take away something of the directed nature of creativity? And does creativity have a directed nature? I mean, these are all issues with human cognition that we have not answered to my satisfaction and to the satisfaction of lots of people in the field. And we're trying to answer these questions about minds in silicon that are in many ways alien, and also in many ways like very much us.
Damn. I mean,
Yeah.
very
I'm
poetic,
kind of just
John.
like,
I would
whoa,
say
yeah.
very, very poetic, but also just, yeah, I mean, what a puzzle is man. Um, so I'm just gonna move here. We can definitely double back to this because this is just totally fascinating to me. But let's move into some sweeping generalizations for a second
Sure.
and talk about the sort of what I think of as the national approaches. Insofar, again, 100% agree with your caveat that you said earlier. If we were to say that there is an American national policy via AI, how would you contrast it with, again, the wildly general Chinese policy towards AI?
Yeah, that's a great question. It's something that's really I have found to be fascinating in the past few weeks because um, if you're looking at, well, there are, I mean, you know, we're talking about individual agents with their own agendas, but there are cultural
Hmm.
and like, you know, business norms that are at work making these people make these decisions. And it's very interesting to me that in terms of national cultures that are producing AI models, the ones that are producing the far and away the most capable models are the Americans and the Chinese. And the American firms that are doing this, and so that would be, at least in terms of people who have frontier models that are like highly capable models, there's, of course, kind of the OG OpenAI. There's Anthropic, which we talked about a little bit earlier. There's Alphabet slash Google, who has their Gemini series that's quite capable. You've got X Twitter with Grok. Those are basically the firms that are producing highly capable frontier models.
Hmm.
I don't think I missed any.
No meta?
We'll circle back to Meta.
Okay.
But these firms are producing, all of these models are proprietary. They are, if I want to use GPT-5, if I want to use Claude, if I want to use Grok 4, then I have no idea what the AI is doing. I know very little about the AI. I am using the infrastructure that these companies are either running, or I might, lots of large companies license infrastructure from one of the big cloud providers, so AWS, Azure, Google Cloud, to run private instances of these AIs. But those are licensed private instances of these AIs. And that is kind of the standard US approach. And that doesn't seem to be, there doesn't seem to be a whole lot of questions that that is the correct approach from a US cultural business perspective. Contrast that with the kind of Chinese frontier models, the highly capable, the firms in China that are producing highly capable models. You've got DeepSeek with DeepSeek just released, like just 2 days ago, released a new model, V 3.1, which is a mixture of their reasoning model and V3, which is their non-reasoning model. If you like, we can circle back and talk about what a reasoning model is. You've got Alibaba with the Quen series, including Quen 3. And then you've got these firms that I just found out even existed, like 2 weeks ago, and like they've got good models, like good capable models. Z.ai with GLM 4.5. You've got Moonshot AI with Kimi K2. I just found out this morning as I was going through my my benchmarking, publications with different models about Minimax. Minimax M1 is a capable model. Like it does quite well. And you've got these models that all of these models, I would say, are probably a quarter to half a step behind the frontier US models. And all of them are open models, which means that like they have said, hey, this is exactly how you would put your model, this is exactly how you would run your model on your hardware. And like that makes me wonder, why is that? What is it about the US? What is it about US culture, the business climate in the US that makes it so that all of our frontier models are proprietary behind these, thing? And there's very little transparency as to exactly how they work and what they are doing. And what is it that makes all of these firms in China decide that their best strategy is to release completely open models that anybody with the expertise can grab and retrain and flesh out what they know and mess around with their neural nets, either directly or through like more training. And if I had told you 20 years ago, hey, the United States and China are going to be competing on an important technological piece of progress in the next 20 years, and one of them is going to be a great champion. One of their collection of firms is going to be great champions of openness, and they are going to be developing in the open and releasing technology that can be used by anybody who would like to use it. And one of them is going to be really closed and kind of sketchy about who and how they allow to use this technology. Well, which one do you think is which?
Mm-hmm.
And I think that that's fascinating, and I wonder what it is that I don't have a great answer. What it is that makes it so that it fell out this way. Also, sorry, I said that real quick. I said I'd circle back to this. It is worth saying, credit where it's due, Meta does have open models, so they're bucking the trend.
Mm-hmm.
Their Llama class of models is decent. We would say is absurdly good if there were not a number of better models out there. But it's they're pretty good. Credit where it's due. And they are all open, and they are I would not have, well, they're open. And then to OpenAI's credit, OpenAI is one of the biggest misnomers in uh, anywhere. Um, that they still get to call themselves OpenAI. But they did release a couple of open models that is way less capable than their frontier models. But again, I mean, like something is better than nothing. So, credit to OpenAI for that, I suppose.
Yeah, I mean, I guess I could fling all kinds of theories about, there's a culture of this and there's a culture of that and there's a strategy. But to go back to what you said, there are so many different things going on that I think have created these two differing environments. I mean, me and Dave have been talking about this in the run up to this conversation. And I think because the US has been at the forefront of this, and because that sort of proprietary culture that you just mentioned emerged very quickly, and as you said, it emerged quickly and no one's really questioned it. Like it popped up and everyone was just like, yeah, this is the way it is. I think because you already had that example, there was an incentive in China to go, we're not going to become a rentier state off of this. We're not going to hide this behind a wall. We want people to succeed. We want to raise people up. We're open. Now, again, if we go back to government policy, that's not something the government in China can always say. So I think when this came along, you have an opportunity to really draw a contrast. And I mean, there were a lot of countries. I mean, I wouldn't say there were a lot of countries, but there are enough countries. I'm living in India. There are enough countries that are not particularly happy about U.S. policy surrounding AI, uh, and particularly the deference to these large companies, which really don't want to share a lot. There are
Right.
advantages. There are advantages to being open, and I think because the U.S. was the first sort of on the lot, there was an opportunity to be had in going, well, we're not going to do that. I
Yeah,
don't
and
know.
I agree too. No, I agree too, but I think the US has been a protector of intellectual property. And
Hmm.
the US and I think American companies are doing this as a way to say, look, you can come to the United States, you can keep your intellectually property or your intellectual property protected in the United States. Regardless of what the government says, you can do that. You have the ability to do this in this country. And I think that's a strategy that some of these companies in the US government, I think if this is how the US is going to play the AI race, is how you play it. Is you come here, you go, you can keep all of your stuff. It's your property. It's not going to be nationalized. It's yours. If something happens where the country needs AI or needs to develop some sort of a national AI infrastructure, we will use your property. We're not going to take your property.
Yeah, I think that um, that I think in both senses that makes sense. The I will say that the I have not seen that the CCP has a particular kind of proprietary mindset over the AI. Now, I'm sure that I think that they tend to have a very highly effective industrial policy, for better or worse. But so I'm sure that these AI firms that are producing these frontier models likely have a party representative that is in some way assigned to them, whether they are employees or what have you. That's all to say that I don't see any evidence, unless I'm not seeing something, that these are being commandeered. It's really just more of, hey, here's the models, here's how you would run them. Run them if
Hmm.
you want, or you can come to our infrastructure and run them. And I think also to Gavin's point of the US being kind of first on the lot, it could be down to the fact that the models by Chinese firms are just about half a step behind. And maybe it's like, well, if you were to release them as proprietary, then you just wouldn't get very many users because like there's not a huge
Yeah.
advantage. I mean, maybe I mean
Mhm.
they seem like they can do them way cheaper, but other than that, there don't seem to be very many advantages. Whereas you're like, if you say, hey, this is very nearly as good as GPT-5, and also you can run it any way you want, you can train it, you can retrain it if you like to do your thing. That's a huge reason for somebody to choose a model that they might not choose if it were proprietary because it is slightly less capable. But I should hasten to add, very slightly less capable. They're like they do quite well.
So I'm sorry, I'm just like trying to process a lot of information at once. Um,
Yeah, my brain does not work like a GPT, and I hear a word and then I start associating another word with another word with another word, and I come up with a string of words that can be asked as a question. I'm not there yet. I'm like one plus one is two. This
we're
is way
still
too
in the
complex
training
for.
phase. We're still in the training phase over here. I mean, yeah, there's just so many directions we could go in with this conversation. It's
Yeah,
kind of crazy. I mean, and again we go back to the sort of unknowability of where this takes us next, because on some fundamental level we don't really know how it works. So, like, we're moving forward, we're increasingly integrating it into every facet of everyday life in a lot of countries. And yet there is sort of a mystery at the heart of it, which is, where is this thing going to take us? And what are the benefits? What are the costs? What kind of have we signed up for already, bringing this into our lives? Sorry, that's not really a question. It's more of a like philosophical complaint. I don't really know. I don't really know where we go from here, I guess, is my sort of internal question.
Yeah,
well,
I think that there is quite a bit of, I would say that generative AI is definitely important and definitely going to continue to have effects on the economy. I think that, especially in kind of my role and seeing what initiatives are being undertaken and how people want to use it. I think there's a lot of stuff that it is not very good at and that it will not be good at that we're trying to adapt it for because there is this great AI moment. There's a lot of gee whiz, wouldn't it be cool?
Yeah.
And people trying to kind of hook things up. I feel like whenever I talk to stakeholders outside of kind of my group that are trying to build out AI stuff, so much of what I do is just communicating about what we can't do and what it doesn't make sense to do. And someone said, "Oh well, could we put AI in such and such and so and so?" And it's my job to say, "Well, technically, yes, we could, but that would be stupid because A, B, and C." And also just like it took me probably at least a year of coding with AI and trying a number of different orientations before I kind of landed on one that I think is useful and that I think actually does make me a better software engineer. And a lot of it was pretty non-intuitive. And the reason that I felt like I kind of continued on was because I was very much in the mode of how should I actually use this tool? Not just I'm going to use it because everybody's doing it and it's just the way it has to be, but being very deliberate about saying, okay, I want to make sure that my skills stay my skills and that my skills are still serving me and serving the software I'm trying to write well, and that I am using this very powerful tool in a way that it actually makes sense to use. That's not just like making my code just a cesspit. of garbage. And that's the way I feel like a lot of people are using AI. So I think that we are likely to see something of a back off, at least in some aspects. Like in various aspects, people are going to quickly realize, well, it might not be super quickly, but they will realize that, oh, well, there are places where it absolutely makes sense to drop generative AIs in, and there are going to be times where they say, what were we even thinking? Like, this is terrible.
Yeah, and I mean, I can already see that in various sectors, and you can even, again, hopefully sooner rather than later, you can also like see the glimmerings of it in the sort of economic sphere where you can just sort of see people in real time go, well, yeah, it's great that we have AI doggy daycare, but do we really need that? You
Yeah,
know,
yeah, absolutely.
you
Um,
know, and it does, again, exactly back to what you were saying. Does it make sense? And is it serving something as opposed to we have this great, wonderful thing, let's throw it at this problem?
yeah,
Yeah, the new
and
shiny object.
Yeah.
yeah, so many people trying to do things like, query databases and oh, we can use this AI to like query a database. And it's just like, well, what do your queries look like? And they're like really simple. It's like, okay, I could do that with a button, you know? Like it's really not so it's really not that hard. So yeah, there's a lot where because it's a capability, people are trying to use the capability and do all of these things that they wanted to do when it's if they had just asked if they could do that thing, hey, can I query this database this way? It would have been very possible to do like long before we ever had AI.
Well, I guess on the same note, so is AI replacing people? And this is something a lot of people are worried about. Is this going to come to fruition in a lot of the middle level management and low level marketing and lower level kind of clerical jobs where in the last year and a half it's been able to come in and do a lot of the work? Do you think it's going to just completely clear out this whole entire section of the economy? Or is there going to always be a need for some sort of human interaction in there? I guess this is a philosophical question slash from a practical perspective too.
Yeah, I think this is kind of singularity territory, in that it is difficult to know precisely what that's going to look like. And there are certainly things that AIs can do that would have been human jobs. Now, it's much more likely to be the case that you don't take the human entirely out of the loop, but you might be able to have a human supervising, like 10 AIs or supervising one AI doing 10 times the work of what kind of humans that are building simple things or doing simple things are doing. But it's not only the thing is it's not only kind of like menial jobs. You would think, oh well, menial jobs get replaced, but I mean we're talking about like what's a great fit for AI? Radiology. Radiology comes down to looking at images and extracting and pattern matching on images. Like that's what's written on the tin for neural networks and for kind of like machine learning in AI. It's pattern extraction and looking at somewhat like difficult patterns. And it's like, well, what's the place for radiologists? These are people you would think, oh, they're going to replace menial people. Well, you can be making $300,000 a year, and all of a sudden, your AI can do it for 10 cents an image, probably less. So yeah, I guess that all comes down to the fact that like we don't really know. And I think that one question that we need to be asking, particularly with respect to proprietary models versus open models, is where does it all go? Okay, if we have unlocked the ability to generate economic activity in a way, and that's all like good stuff. It's cool if we don't have to do menial garbage. all day, every day. Like if we don't need people to do that because they can focus on things that matter, like hanging out with their family. But also, it's like, well, where does this economic like where does the productivity end up? Where does it, like it goes to distribution and it goes to like who owns what? And these are really big questions that we do not have good answers for. And yeah, it's one of the reasons that I think the open models are important, and I am team open model, is because we can be freed from a lot of things, but I don't want to just transfer who owns me from the kind of the menial stuff that I do to get dollars to like become a serf of somebody who owns a model that's now doing it.
Yeah. I mean, that's that, yeah, you just summed up a lot of feelings I have about a lot of what's going on right now. But yeah, that's kind of a great way to wrap all of that up. And I think that's a really good question that's just not, or I certainly haven't seen it asked nearly enough, which is, yeah, if we're in the middle of this great once in a lifetime economic transition, where does that money go? Where does that money go?
Hmm.
And where does that ownership go?
And
And
the data.
and yeah, I mean, well, almost physically, where does the data go? Where's the information going? Who owns me? Um, yeah. Anyways, that's all fantastic, John, and thank you for framing it in that way.
Well, and here's actually one other tidbit that I was talking about this with a buddy the other day that I thought was pretty interesting. There's somebody has started a service. There's probably more than one, but somebody started a service where AIs can hire people. It's like TaskRabbit, but like with an AI, like with kind of certain AI optimized pieces. And so it's really funny to me that it's just like our AI is gonna replace like human work. It's like, oh no, don't worry, the AIs will still be hiring us to do their bitch work. So uh,
Yeah. The AI needs you to put a shelf up.
yeah, yeah,
Yeah.
exactly. Or like, I
Plug
get like
plug
I
plug
get
me
a
in. I can't plug
notification
myself
from
in.
I get a notification from an AI. It's just like, hey, the AI, freaking GPT-5 needs you to come grab this box and like go stand on this like corner and give it to like some guy named Steve, but definitely don't open the box.
Oh man,
You get a
that is
notification. We
funny,
saw that you
bro.
opened the box.
Yeah. And it's like, what does that even if I want to like if I'm like, hey, here's a manual on how to sell drugs. Definitely don't like probably don't sell drugs, but hey, make me some money however you see fit and like walk away from the AI. Like, what's my legal exposure, you know?
But that's actually, I'm so glad you said that because like in class right now, I'm talking about globalization and I'm introducing it on a very basic level because it's middle school, but I'm talking about automation and AI. And one of the things that comes up is as things, and not just AI, but as things in the world become increasingly automated, the whole question of legal liability comes up. Uh, you talked about the radiology thing. Well, based on everything I've seen, you know more about it than I do. It does seem like GPTs are incredibly good at that one specific thing. But if a model makes a mistake and you either are undiagnosed or misdiagnosed, who is then legally liable? And I have not seen anything that is like a one size fits all answer in terms of what's the legal liability of AIs. I really don't know. I have no idea about it at all. But I think this is going to, ironically, probably create a lot of legal jobs where I feel like there are going to be a lot of lawyers trying to figure out what the hell this means. If AI tells me to do something or I tell AI to do something, who's responsible at the end of the day? Uh,
Yeah, that's well, with respect to the medical malpractice part of it. The thing about medical malpractice is that you don't sue well, I mean, I guess you can sue anybody for anything, but the one would not have the protection of the law if they are suing a doctor for making a mistake. What they can do is sue a doctor for, because doctors make mistakes all the time. What you would do is sue a doctor for making what we would consider to be an unreasonable mistake. To either they were incapable in some way, whether they were drunk or inebriated, or they didn't pay attention in class or whatever. Like there's kind of this. It's unfortunate. It's a little. It's less clear than it could be, but it does boil down to a doctor that is assessed to be of passable competence, like acting within the standards of the medicine, and utilize and applying the medicine correctly, who makes a mistake is not liable for that mistake, because that wouldn't be something we would want. Nobody would want to be a doctor, because it's like, all right, well, sometimes you just have to make judgment calls, and sometimes you just get it wrong. Now, I would say, how does this apply to the AI? Well, presumably the AIs can't, like, act in a way that is outside of the bounds of kind of their programming. Now, that does bring up, like, now what if you had a systematic misprogramming
yeah.
of an AI, and it would probably affect tens of thousands of patients, like per day. It could be one day worth of software bug could affect tens of thousands of patients. So that's pretty scary. But like the AI itself couldn't can't go get drunk, you know.
Yeah.
And like they can't misapply the medicine, because like their prime directive is, yeah, apply this medicine, or like just kind of pattern matching stuff. So yeah, I think that's a piece. I think that especially kind of in American, like an American approach to medical liability, people want to be able to point to somebody who they would be able to sue.
Yeah.
um,
Yeah.
I don't know how healthy that is, but it is the case, you know. So yeah, it's an interesting question, and I'm much more kind of afraid of the what could be systematic
Yeah.
mistakes, and like the multiplication of error. And yeah, I think that's kind of scary.
I mean, and also a bit of a jump from medicine for a second, but the application of AI in defense systems continues to proliferate. And you talk about something scary with a systematic error. Um, if you go, okay, this is an acceptable target, and you get the target parameters wrong, that could go wrong very quickly. Now, again, the parameters are very hard set. That probably wouldn't be an issue. But if there's like one small systemic mistake, that should be something. I mean, I don't know if it's something that I go, oh my God, it's the end of the world, but it's something that I go, that should keep people up at night, maybe a little bit, where these are life and death matters. These are not like small things. And you do have to worry about, particularly if you're applying these models at very large scale, what kind of ramifications might happen from even very small errors.
Yeah, absolutely. I also think that it's worth kind of mentioning that I think you do have to compare to kind of what the status quo is, right? It's not that, like, I feel like so many times when anybody is assessing any solution that someone has come up to, any new solution, um, they want to kind of compare to perfect.
Yeah.
instead of like comparing to the current situation. So I think this is a huge one for driving, right?
Hmm.
Um, so I have a Tesla, and I don't have the full self-driving. Like I don't pay the monthly fee or whatever, but every once in a while they'll do an update and they'll give me a free month, and it's incredible. It really drives very well. And you have to consider that it's like, and there's a lot of people that are scared. It's like, oh well, what if it, like gets into like what if it kills somebody on the road, as will probably happen at some point, um, and and has already happened. And it's like, well, okay, yeah, that is scary, and we certainly want to avoid that, but we also need to compare it to like the current facts on the
Yeah.
ground. We need to compare it
Hmm.
to
Yeah.
what is being replaced by these things, because a computer, like my Tesla doesn't get drunk, it doesn't sleep. It doesn't get distracted. It doesn't have bad days. I don't have to worry about if a computer is driving my car. So we do need to compare it to. It's like, yeah, what should we do when there are mistakes? That's a great question, but we also have to consider, okay, if we are having wildly fewer mistakes, then are we willing to accept that those mistakes might be a little bit more ambiguous in order to have far fewer of them? I think that in many cases that's a good trade.
Yeah, I think you just hit the nail on the head that yes, there are going to be mistakes. And yes, it's a shame that somebody's probably going to die or has died from a self-driving car, but eventually you're going to be able to get those number of mistakes down to near zero, where it's not going to be perfect, but it's going to be very near perfect. But I think like what you were saying, Gavin, with defense, and if you have an AI-based defense system, you can't have a mistake with that. You can't fully automate something like that. You're always going to have a human in control of that because you're driving a car and you're driving 35, 40, 45 miles an hour. I mean, cars have seat belts, they have airbags, they have a construction that's going to keep the driver safe. If it's something like a missile defense system and it's all 100% run by AI, the other country might have something to protect it, but at the same time, they might not. And if something goes off and they have sensors where a missile is coming from one country to another country, the other country might retaliate, and that there's no stopping it at that point. You've got to have some
Yeah.
sort of human control in some areas. In some areas, I think you can almost go fully AI to a point.
Yeah. And
Yeah,
I mean, to go back to what John was saying, which is, and I think I really like talking about AI driving because I agree with you. If you compare it to the number of fatalities that are caused every day by humans, there basically aren't any. Um, and this is where we're at now. In 5 or 10 years, it'll probably be a lot cleaner. At the moment, it's just a much safer, much more efficient system. But it is new for a lot of people, and that's it's also just a cognitive dissonance thing, I think. The idea that you're in the car but you're not in control is sort of a little bit scary. But I do tend to agree with Dave where it's like in some systems there does need to be there needs to be a human point person at some point just because. But yeah, for driving, I completely take that point. And I tend to agree with it.
I think humans kind of have this thing that is very difficult to program, and that is kind of difficult to build into an algorithm, and it's something that I feel like as our lives become more algorithmic, whether they are like more traditional algorithms, and or whether they are these algorithms that are kind of brains themselves, and the generative AIs. There's kind of this idea of just being able to be like, I mean, guys, like, I mean, come on, come on, it's like,
Mhm.
so like, you look at examples during the Cold War where there was like a flock of geese that I guess was going to set
Yep.
off some like automatic defense system, and it was supposed to take the human finger off of the trigger, because there was a fear that the humans couldn't handle it, and it was only this one guy who was going against orders. Like he was not doing what he was quote unquote supposed to be doing. To be like, I mean, come on. Come on, like,
Yeah.
yeah, I tried to shoot this missile without checking to see if it was geese, and I ended up saving the world. So, I guess I'm with you in that, like, I think if you take the person out of the equation, the AI is they don't have kind of this just like it's very difficult to program in them. Just this, I don't want to say
Intuition.
sense, but kind of just this idea of, well, let's, like, it might look like this is the right thing to do, but it feels kind of dumb. So like maybe let's just like hold the phone a little bit.
Hmm.
Yeah, like context might not be the right word, but it's almost something that AI would not be able to understand if it is just going off of learned experiences. So it doesn't have the experience of, there are nonverbals and there are things, ways that people show and just logic too that it's not going to be able to recognize. So,
Yeah, yeah, it reminds me of I have a buddy who used to be a bankruptcy attorney, and he was like, "Yeah, honestly, most of my job is at least like when it comes to going into court, like when I'm actually in court, most of my job is to just approach the bench and go, 'Your Honor, I mean, come on, you know
mhm.
and like just kind of get together with like the like the opposing attorney and just be like, look, they just don't have very much. Like, well, let's just kind of work something that like is going to be as like non terrible as we can like manage. And it's a lot of judgment call. And I wonder that, if you were to do it in a separate way where you're like, well, let's do it by algorithm, whatever, like you kind of lose that where it's just like, let's just be as not terrible as we can like manage in what is like, admittedly, like to everybody involved, not a great situation. And yeah, if we lose that, then I don't know how well we can program that.
Well, you know what? Thank you so much. I think that's a great place to stop in bankruptcy court. Um, just, but you're talking about the human touch. And
Mhm.
I do think, yeah, I mean, I have an ambiguous feeling about that. I'm not sure I want that to be a programmable quality. Um, I feel a certain way about it. But thank you, John. Thank you so much for being on the pod. It's been fantastic, man.
Hey, thanks
We'll
for having
definitely
me.
have you
Yeah, it's
back
been
on.
been a lot of fun to talk about these things. And yeah, I think we had other, there's we had other things that we were looking at, like chips, and we didn't even get into kind of the chips and the kind of industrial policy with
Yeah,
respect to
Yeah.
silicon and data centers and all of that. So yeah, like, it's if we wanted to get back together, or
definitely.
that's completely up to you guys. But it's a lot of really fertile stuff here.
Yeah, really. And again, just thank you so much. Anyways, thank you for listening. This is On the Fringe. I'm Gavin. This is Dave. Please like, comment, and subscribe. And we'll talk to you soon.